This video covers the following theorem. So, if you have a graph and you have two distinct vertices, any walk from connecting the two vertices, which is of minimal length, must be a path. Now, before starting, we're going to go over a couple of definitions. A walk in G, definitions. A walk in G is a sequence of vertices, v1, v2, v3, dot dot dot, up to, let's say, vk, where for all vi, vi plus 1, the edge exists in the graph. So this edge is in E. Okay? And the length is the number of edges in this case. It doesn't really matter. Some books will say that it's the number of vertices. Now, what is a path? A path is a walk with all distinct vertices. Okay, now let's get to the main theorem. Okay? Proof. First, actually, we'll handle the case if v equals w. So, if the two vertices are actually the same, then the minimal walk is the walk of length 0, i.e. it's just the vertex by itself. That's the walk, and this is also a path, you can tell. Okay? Now assume v is not equal to assume vw distinct. Let's let this walk equal v1, v2, or start at v, v1, v2, dot dot dot, w. Okay? Assume the length of w, let's say it's k, which is minimal. Okay. Suppose that w were not a path. Okay? This means that there exists a repeated vertex. Okay? So, exists, and just for simplicity, I will name these endpoints of the walk, vk, with v0 equals v, and vk equals w. Okay? So suppose that w were not a path. Then there exists an I and a j, which are distinct. Okay? which have the same vertex. Basically, if it's not a path, then there's a repeated vertex, such that vi equals vj. Okay? Now, consider the following walk. V0, V1, Vi. Okay? So you walk up to Vi, and since Vi is equal to Vj, we can then jump immediately to Vj plus 1. And continue until Vk. Okay? And this walk does not contain Vj. And by that I mean, i.e., does not contain the duplicate. As in, it does contain Vj because it's the same as Vi, but it doesn't contain it the second time. Okay? Thus the length is decreased by at least 1. And this would happen in the case that Vi and Vj are adjacent, which, depending on whether you consider simple graphs, this would be possible or not. This proves the result.